Welcome back to the deep dive. Today we're looking at a small but really crucial piece of gear. It's the Datavideo DC-91.
Yeah, the HDSD-SDI audio embedder. And our mission, really, is to understand why a box like this even needs to exist in a modern setup.
Right. Because you think everything is digital now, but it's not.
Exactly. Think about it.
Yeah.
You've got this perfect high-end digital video signal, probably running over SDI. But your audio sources, your mics, your mixer, that's often still analog.
So this is the bridge.
It's the crucial bridge. It takes that, messy, real-world analog audio and pushes it cleanly into that big digital video pipeline.
Okay, so let's unpack that. The core function is embedding two channels of analog audio into an SDI stream.
That's it in a nutshell. But the real story is its flexibility.
How so? Because productions are always changing formats, right? One day it's HD, the next it's something else.
And this box is built for that. It supports 3G, HD, and even legacy SD-SDI signals.
And you don't have to tell it what's coming in.
Nope. It automatically detects and switches between them. So you can be running a brand new setup at, say, 1080p 60 and plug in an older analog source without a single hiccup. No signal mismatch.
Now, for the producers who live and die by the spec sheets, you mentioned a whole alphabet soup of standards. SMPTE 259M 424M.
Yeah, and that stuff really matters.
Why, though? To the person on the floor, what does that mean?
It means it meets the quality checkpoints for professional broadcast. It's a guarantee that your signal is, legally compliant for network feeds.
Ah, okay.
And on the audio side, which is its main job, it's sampling at 24-bit resolution, 48 kHz.
Yeah.
That's giving you maximum headroom, maximum quality before it even touches the digital stream.
I see. So it protects the audio integrity. But what about the video it's passing through this box? Does it mess with the picture?
Great question. And no, absolutely not. The video pass-through maintains full 4.2.2 10-bit color precision.
So in layman's terms,
The video comes out just as clean as it went in. The audio is simply added on top without any degradation to the picture.
so the digital side is rock solid. Let's talk about the analog side. Where does the audio actually plug in? I'm looking at it and I see 4 inputs.
Yeah, 2 mini XLRs, which are balanced professional connectors.
And 2 RCAs, which are more, consumer grade. Why the mix?
That mix is actually a huge operational benefit. It's not a compromise, it's a feature. It lets you be incredibly flexible with your sources.
So how does that work? How does it decide what goes where?
The logic is pretty smart. Mini XLR1 and RCA1 are mixed together to create channel 1,
Oh, I see.
and the same for channel 2. So you could take a pro shotgun mic feed on the XLR and mix it with, say, a house music feed on the RCA, all onto one channel. It simplifies everything.
That is actually really versatile. Now, the controls, they look a bit old school. I see physical DIP switches for audio levels.
Yeah, no software menus here.
Oh, what's the advantage of that?
When you're under pressure in a remote setting or a fly pack, physical switches are just fast and reliable. You know what you're getting.
And what are the options there?
You get precise gain control. You can set it to 0 dB or boost or cut by 6 or 12 dB. It's all about matching your incoming audio to the correct professional SMPTE or EBU levels before embedding.
And you're not just guessing.
Right at all. You got those 2 rows of LED indicators right on the front, so you get instant visual feedback on your audio levels.
So at the end of the day, for you, the producer, this DC-91 is a really robust, almost necessary utility box.
It really is.
It just seamlessly marries these 2 totally different formats, analog audio and digital video, into one clean signal.
It solves the embedding problem so elegantly. But if we want to connect this to the bigger workflow, it raises an interesting question.
Okay.
Since this device, the DC-91, does such a good job embedding that audio into the signal, what complexities does its counterpart have to deal with?
You mean a D-Embedder, like the DC-90?
Exactly. What challenges does that device face to pull that professional-grade audio back out of the digital stream and turn it back into clean, usable analog audio without adding noise or latency? That's the other half of the puzzle.